Okay. I think we're recording now. This is a new software. This is a new software package, and so don't be surprised if it doesn't work quite right. I was planning on using the Canvas conference feature, but unfortunately, it's not working this morning. I don't know if it's because Canvas is overwhelmed because everybody in the entire United States and probably worldwide is all trying to use Canvas at the same time for conferencing. So this is a new software package I haven't used before. Let's see if it works. Okay, so let me just see your comments here. Okay, nothing new there. All right, so you guys understand here is how the class is going to run. We're going to be meeting here online 3 times a week, Monday, Wednesday, Friday, for about an hour or maybe less. We'll see how long it takes. And every time that we meet, I'm going to post a little quiz, a few minutes, well, sometime after the online class is over. I'm going to post a little quiz, and then in order to get credit for attending, you need to take the quiz, and I'll keep it really simple, really simple. So don't worry about the quiz at all. Okay, so Simon is just saying that John's with you. Okay, good to hear. All right. Okay, so have you guys been looking at the Arduino primer that I put online? Can everybody just give me a yay or a nay as whether or not you've been reading that? Okay, so Simon's saying yes. Marshall, no. Bad boy, Marshall. Brian, Danny, Sky, yeah. Everybody else, yes. Okay, good. Taking notes on it. Okay, good. Glad to see that. Oh, so Marshall's not the only bad boy, I see. Okay. All right. Well, that's going to be, okay. So that's going to be our next assignment. Let me tell you what I would have done had school not been canceled. You remember the burglar alarm that we all made? Okay. So the burglar alarm was super simple. There was really no electronics in it. It was all just programming the Arduino. So it was my intention that after we all did the regular burglar alarm that used the solar panel, then we would learn a little bit about electronics and make a better version of the burglar alarm, a version that does not use a solar panel. And the reason for that is because solar panels are pretty expensive. And so if we try to sell a burglar alarm based on a solar panel, our competition might be able to come in and sell a cheaper version, because it turns out that if you use another electronic element called a photoresistor, that you can do the same thing for a whole lot less money. But in order to do that, you need to know a little bit about electricity and electronics. And so it was my intention that that was going to be the next thing that we do. I'm still going to try to work that out, but we might have to change plans. But for right now, let's go with that, and let's assume that what we're going to do is we're going to learn a little bit about electronics. Okay, so in the Arduino thing that I told you to read. In fact, tell you what, let me get that up on the screen here. Whoop. Okay, that didn't work the way that I thought it was going to work. Okay, so hang on a sec. Hello, everybody. Let me see how I can get that back. Okay, here we go. Okay, I think we're good. All right, so here is the Arduino thing. Okay, can everybody see that? Okay. Okay, so I see a lot of people saying yes. Okay, good. All right. Okay, so on this Arduino thing, okay, can you see? Hang on a sec. My computer is doing weird stuff. Okay, well, there we go. All right, can you see the hand Okay, good. Moving around. Okay, so this Arduino thing that I asked you guys to read, it talks not only about how to use the Arduino, but it also talks about to how electronics works, how electricity works, and everything. And so that's the thing that we're going to use next. So here's your assignment, which is going to be due um, at 11 o'clock on Friday, right before class starts. Is I want everybody to read this Arduino thing. So you can see that here, can you see the little hand moving around? Boy, the little hand, there's a lag time between when I move the hand and when it shows up. Okay, but anyway, so here, it not only tells you how the Arduino works, but it also tells you about electronics as well. Tells you how some things, photocells, LEDs, on-off switches, okay? It talks about other things that are electronics related. And this is what I want everybody to learn about next. So I see on the comments here that most of you have already read it, so that's good. But a few of you, I think, have not. Okay, so let's see, let's go. Okay, so you see this page right here? This page is really, really important. So voltage, let me put it up here. Okay, so can you see? Okay, so voltage, current, resistance, Ohm's law, those are all things that you need to know about. And so let's talk about it right now. Voltage that's a word that I'm sure you guys have heard all your life. Can somebody in the comments box just type in, what do you think voltage means? What is the definition of voltage? Some of you type it in, let's see what you say. A way to measure. Okay, that's a true statement, but not especially helpful. Electric potential. Oh, okay. A way to measure electric potential. Okay, it sounds like somebody has been reading the handout. Okay, so what is electric potential? If you don't know what electric potential is, then that's not very helpful. So let's see. Okay, and it's measured in volts. So yeah, everything that you're saying here is true. But I mean, if I was a junior high school student and you were trying to explain to me what voltage is, and what you said was, well, it's a way to measure electric potential, my response would be, huh? So try something else. Somebody else try something. Let's see if you can type it in a way that a junior high school student would be able to understand. Energy. I can understand why you would say energy. It turns out it's a little bit more complex than that. Let's do one more person. Let's see if one more person. How much electricity is flowing? That's a very good, very common misconception. So tell you what, I won't make you guess anymore. Okay. Okay, so if you look at the bottom of the screen here, you'll notice that we've got something that's supposed to illustrate water flowing through a pipe. Okay, so right here where the hand is right now, okay, that's supposed to be a water tank that has water in it. Okay, and the water tank is pressurized. And depending on how much pressure we put in the pump, that determines how fast the water is going to flow through the pipe. So if we pump this thing up to a really high pressure, you're going to have a lot of water flowing through this pipe and coming out the other end. So you can think of electricity very much like you think of water. A battery has electrical pressure. So if a battery has high voltage, what that means is that the electrons are jammed in there really, really, really tight. We've really pressed them together really, really tight. And so, boy, they really want to get out, because you guys know that like charges repel and opposite charges attract. I trust you learned that back in junior high school. So if you take a whole bunch of electrons that all have the same charge and you pack them together, they don't like that. They're going to try and get away. If you pack them really, 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 really tight, then what you've done is you've created what's called high voltage. So think of voltage as the equivalent of pressure. All right, so that's voltage. So if there's a lot of pressure in this water tank, that water really wants to go spurting out. Okay, so that's voltage. All right, so current is the same thing for electricity that it is for water. It's how much is flowing. So if you think of the current in some river, and you say, well, okay, I want to measure the current in this river. So what you want to do is you want to stand by the side of the river and you want to count how many gallons per minute are flowing past you. That would be the current. All right, so with electricity, we do it the same way. So you see right here where I've got the hand right now is some point here. We're going to talk more about it later, but let's say we pick some point. It doesn't matter. You can pick any point you want. And you're going to look and you're going to see how much electricity is flowing. So one way that we could do it is we could count how many electrons per second pass by us. But that would be an absurdly large number. Okay, that would be like standing by the side of a river and trying to measure current by counting how many molecules of water per second are going by. It would just be absurd. Nobody would do that. Okay, so with water, what we do is we have this big group, like we define a bucket and we say, okay, we're going to call this a gallon. And so we're going to say how many gallons per second go by. That would be the water current. So we're going to do the same thing with electricity. We're going to say how many gallons of electricity, except we're not going to call it a gallon. We're going to call it a coulomb. So coulomb is spelled C-O-U-L-O-M-B. A coulomb of electrons is kind of the equivalent of a gallon of water. Okay, so what we're going to do is we're going to count how many coulombs per second pass by a certain point, and that is the current. Okay, so far so good? Somebody type in a yay, nay. I'm worried that the sound might be cutting out or something. Okay, so I'm getting a bunch of yays. Okay, good. So we'll continue then. All right, so we've talked about voltage. We've talked about current. Okay, now resistance is another really, really important thing. So if you look down here at the bottom of the page again, so you'll see they've got this thing, which is kind of like a nail that they've stuck in the water, or maybe a screw is a better thing. So they've taken this kind of a screw-like thing and they put it here. So basically what they're doing is they're pinching the tube. So if they pinch it, then that makes it harder for the water to get through. So they're increasing the resistance of the tube. Okay, so the more they pinch it, the more resistance it has. All right, so what we're going to do is we're going to set up an equation where we try and figure out how is the voltage related to the current and the resistance. Okay, so, and in this equation, we want to use one-letter abbreviations. Okay, so voltage, we're going to use the letter V in our equation. Resistance, we're going to use the letter R in the equation. So for current, you might think that using the letter C would be the appropriate letter to use in the equation. But it would be confusing because anybody remember what it was that I said that when we're measuring current and we're counting how many electrons per second are going by, we don't actually count the electrons. There's a thing that's kind of like a gallon of electrons. Anybody remember what that one was? What did I call it? It started with the letter C and it wasn't current. Somebody type that in here. Coulomb, very good. Okay, except it's only got one. Tell you what, let me go in here. Let me type in, you know what, it's not gonna let me type it in. Okay, hang on a second here while I type it in. Okay, all right. You see where it just said Coulomb, C-O-U-L-O-M-B? Okay, so a Coulomb of electrons is like a gallon of water. Okay, so Coulomb, the letter C is already taken. So for current, we don't want to use the letter C. So what we're going to do instead is we're going to use the letter I. And I is the word that's used in French for current. And so that's where it comes from. Okay, so now we got to figure out an equation that's going to relate voltage, resistance, and current. Okay, now some of you already know that that equation has a name. It's called Coulomb's law, or sorry, called Ohm's law. Ohm's law. Okay, so if you look over here, you can see that Ohm's law can be written several different ways. Up here at the top, this is my preferred way of doing it. It's the way that I think is easiest. So I, remember I stands for current, okay? So I is equal to V over R. So that one I think is really easy to understand because what is V? V is voltage, which is the pressure, okay? So it makes sense that, go back to the water analogy. If we increase the pressure of the water that's in that tank, it makes sense that more water is going to come spurting out that hose. So it makes sense that V would be up on top of the equation there, because the bigger V is, the bigger the current's going to be, okay? And it also makes sense that resistance would be on the bottom there, because resistance, remember, that's where we tighten the little nail here, or tighten the little screw, and it pinches the hose closed. So the more resistance we have, the less current is going to flow. So it makes sense then that R would have to be on the bottom, because the bigger R is, the smaller I is going to be. Okay, so this one up on the top here, that's the way that I remember it. But I'm sure you guys are good enough with algebra to know that you can rearrange that any way you want. Just do a little bit of algebra and you can rearrange it so that R equals V over I, or V equals R over I. Okay, they're all going to work out. Okay, so this is called Ohm's law. And so in the quiz that I'm going to write up after this class session is over, I'm going to give you a couple equations where I say, the voltage is such and such, say 12. Say we've got 12 volts, and we've got a resistance of 3, whatever units it is we measure resistance in. So then how much current is going to be flowing? So that's what we're going to be doing. Now, while we're at it, what are the units for each of these? So the units for voltage, that's pretty simple. We just call it volts. Okay, the units for resistance, we're going to call that ohms. Okay, yeah, volts, ohms, and amps. Very good, David. Okay, and by the way, David, if you hadn't got that right, I would be very upset with you. And the reason I say that, just for the rest of you to know, David was in my electronics class. So good for you, David. I'm glad to see you learned something. Okay, so resistance, the unit that we're going to use for that is called ohms. And then current, the unit that we use for that. Now, technically, the unit for current is actually coulombs per second. Because remember, like water, it's gallons per minute of water. So coulombs per second of electricity. So coulombs per second is a correct way to say it. But most electricians, they get awful tired of saying, 3.4 coulombs per second. They don't like saying coulombs per second. So they've made up a new unit called an ampere, which is abbreviated as amps. Okay. And so instead of saying the current is 3.4 coulombs per second, what we say instead is it is 3.4 amps, but it means the same thing. Okay, so volts, ohms, and amps. You need to know about those. And in the quiz that I'm going to write up and post later today, there will be questions about that. Okay, so if you've read this little handout here, it should be pretty easy. So now down here in the bottom here we've got a battery. You can see it's a 9-volt battery, and we've got this red button here, which is a switch. So when we push the switch, it'll go on and it allows the electricity to flow. And it's just think of it as water flowing. That's a great way to think of it. So the water flows out of the battery, and if the switch is on, then it goes through the lamp and comes back, and the lamp lights up. So the picture on the left there, that is easier for people to relate to, but the picture on the right here, this is easier to draw. And so most of the time, what you see on the right is the way that we're going to be doing it in this class. Okay, so this funny symbol here with these lines that are long and short, Okay, that is the schematic way of saying a battery. This thing right here where the arrow is, right now the arrow has swung to where it's not connecting. So the switch right now is in what we call the open position, or you could think of it as it's the off position. Electricity is not going to flow because the electricity wants to come out here and wants to go through here, but it can't get through here because it's broken. So if we were to push the red button, then this switch here would close and it would allow electricity to flow. And when electricity flows through the lamp, that's when the lamp lights up. Okay, so this thing over here on the right is called a schematic. And that's the way that we're going to be drawing most of the time. But this schematic is intended to represent what you see on the left. Okay, direct current and alternating current. All right, so direct current is what you get if you're working with a battery. And that's what we're going to be doing in this class. We're not going to be doing alternating current. If you were to somehow measure the electricity that's coming out of the wall socket in your home, what you would, which by the way, you should not do because you could die. Don't go taking your voltmeter and sticking it into the socket. Even though I know some of you are going to say, oh, but I've seen my dad do it. My dad can do it safely. And I will admit it can be done safely. But if you are not careful, you could kill yourself. So never, never stick anything into a wall socket other than a regular plug. Okay, so, but if you were to do that, and you could do it safely, what you'd find is the electricity that's coming out of the wall is not like that in a battery. The electricity coming out of a wall, it flows one way for 1/60th of a second, and then turns around and flows the opposite way for another 60th, and then back the first way, and then back the other way. So it keeps going back and forth, and that's called alternating current. In this class, we are not going to deal with alternating current. We're going to deal with direct current, which is what you get out of a battery. And with direct current, the current always flows one direction. It never changes direction. Okay, so you can see over here now the little cartoon lady is saying, okay, now that we reviewed some basics of electricity, let's get back to the Arduino. Okay, so everything from this point on, you should already know because we have already done this. We did the Arduino first and the electricity second. So everything that you guys see here, this should all be reviewed for you. All of this stuff, void setup, void loop, pin mode, digital write, all that stuff, that should all be reviewed for you, okay? This thing that you see right here, this is an LED, which stands for light emitting diode. You can think of it as just a light bulb. Now, it actually has some really cool features that if you take my electronics class, you'll learn about. But for right now, just think of it as a light bulb. Okay, so LEDs, you can turn them on and off. Okay, so everything in the latter part here, this should all be reviewed. And so there's no point in me talking about it. I think you guys already know it. Okay, so here is your assignment. Well, actually it comes in two parts. Part one is as soon as I close this class session, I am going to write up a little quiz. I've already started the quiz, but I didn't want to finish it because it kind of depended on how this class session went. So now that we've talked about a few things, I'm going to go in and I'm going to modify the quiz. And so give me about an hour or so to do that. And then I'm going to post the quiz on Canvas. And I promise you, it'll be really simple. If you paid attention to what I just said, and if you've read the Arduino handout, you'll be fine. And so that one, I'd like you to do that today before midnight. Okay, and then, so that's a quiz, that's not your homework. Your homework is going to be another assignment, which I've already posted. At least I think I posted it. All I've done, these last couple of weeks have been so hectic, I'm starting to wonder when everything's all kind of running together. Okay, so Novelia is asking, will I send out an email once the quiz is ready? No, I'm not planning to do that. What I'll say is just check in later this afternoon. for sure by 3 o'clock, I'll have it posted, and probably before then. So just go on Canvas, and you'll see it and take it, and it'll be really easy. Okay, so you've got two things you need to do. One is take the quiz, which I promise will be easy. And then the second one is do the homework assignment, which will be a little bit trickier, but not that much. I don't think it'll be too bad. If you guys think it is, let me know, and we'll adjust it. So that's pretty much everything that I needed to talk about today. I scheduled 1 hour for the class here, but I see it's only been a half an hour, and we've pretty much talked about everything that I want to talk about. So, okay, so what is the homework assignment, David is asking? And the answer is that it posted on a Canvas. Let me just check here. Let me go on Canvas and see if I did, in fact, maybe I didn't publish it. That has sometimes happened. Okay, hang on while I check Canvas here. Okay, so basics of, no, that's not it. That's the one that's due. Well, tell you what, when I was originally doing this, I had it due March 30th, but that we don't need to do that. Okay, so tell you what, I am going to change this thing. Instead of having it be due on March 30th, I am going to, oh, wait a minute. Wait a minute, timeout. Okay. I can see that I have, that's different. So I have not yet posted the homework assignment. Okay, so sorry, shame on me. So tell you what, I'm going to do the same thing with the homework assignment that I'm going to do with the quiz. Give me a little bit of time to tweak it, and then I will post it today before 3 o'clock. And then it'll be due at the beginning of class on Friday at 11 o'clock. Okay, so I have not yet posted either the homework or the quiz. This other thing that you see on here, tell you what, let me unpublish that real quick here. Okay, the thing that says basics of electricity, voltage, current, resistance, and Ohm's law, I'm gonna modify that. Okay, waypoint, yes, you are right, Simon. That is a waypoint. You know, I forgot. I didn't bring the wig home with me. Maybe what I should do is I should run into school this afternoon and get the wig. Okay, it's a good point. Okay, so anyway, that's the plan. Does anybody have any questions? Okay, Danny is saying that you agree. Okay, I've got a couple screens here. That's why you see sometimes I look over here, sometimes I look over there. Okay, so okay, just to clarify. Okay, go ahead. So Danny, what is it you want to clarify? Okay, so Danny's saying, what is the homework? Okay, so Danny, the answer is the homework is not yet on Canvas, but I will post the homework on Canvas later this afternoon. It'll be on there for sure by 3 o'clock this afternoon, probably earlier. There will be two separate things. One will be a quiz, which will be super easy, just to make sure that you guys watched this video and understood what I said. It'll be super easy. And then the second one will be an assignment that's a little bit more involved, but not much. And so I'd like you to do the quiz by today at midnight, please. And then the homework assignment, just have it, turn that in by 11 o'clock on Friday. Okay, does that answer your question, Danny? I'm not seeing anything posted yet. Not any questions. So Danny, give me a yes or no. Oh, okay, yes, and that will be on Canvas. You are correct. Okay. Anybody else got any questions? What? David, what language is that? That looks like Russian. Somebody want to translate? It is Russian. Okay. Somebody want to translate that for us? It means no questions. Oh, good. Okay, good. I learned something new. Okay. All right. Well, I am going to stop the recording. Maybe. if I can, okay.